Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Kamil Fitri bin Adzuan, Matric number B051720009. Today, I'm going to present about my final year project, which titled Characterization of Titanium Dioxide Powders Synthesized Using Titanium Sulphate via Hydrolysis Method. And I am supervised by Madam Siti Rahmah Binti Shamsuri. Okay, for the first topic, which is introduction, so this titanium dioxide has gained considerable attention due to its important role in many applications, such as photocatalysis, environment purification, self-cleaning on the surface of building, and many more. This titanium material occurs in three crystalline forms, which is rutile, amethyst, and also brookite. Among these crystalline structure, the amethyst possesses an excellent photocatalytic properties compared to other two structures. The properties of titanium depend heavily on the size, morphology, and crystalline forms, and this character is relying on the processing condition. Various techniques has been used to synthesize the materials such as PVD, hydrothermal, hydrolysis, CVD, sol gel, deep coating, and others. So in this project, we demonstrate a fabrication of anodized titanium dioxide powders by a simple hydrolysis method using titanyl sulphate, TiOSO4, as the starting material, and discuss further the effect of stirring temperature and time on the structure and properties of the titanium dioxide powders. Problem statement is many papers and journals have been published on the synthesis of anodized titanium dioxide, which include CVD, sputtering, hydrothermal, and sol gel. Most of these techniques require a large amount of energy, which form at high temperature and also need an expensive equipment. And among these techniques, the hydrolysis required a simple equipment and easy to control the parameters during the synthesized process of the product. The objective of this experiment can be categorized to three different objectives, which is to synthesize the titanium dioxide powder using simple hydrolysis technique, using titanium sulphate as main material. Second, to investigate the surface morphological properties of synthesized titanium dioxide powders using SEM. And lastly, to characterize the structural and physical properties of the synthesized titanium dioxide powder using XRD and also FTIR. The scope of the project is for the synthesis of titanium dioxide powders, the hydrolysis technique will be used. Temperature during hydrolysis process is considered to be these project parameters. SEM was used for the titanium dioxide powders morphology characterization, while for the physical and structural investigation, the XRD and FTIR will be employed. So, for the second topic is about literature review. So from this, we can see this is the three main literature about the development of titanium dioxide powders. So the first one is the porousness of titanium dioxide powders, which is by the author C.C. Palacio. And this study found that the phase and the structure of the coating affect the material mechanical properties. Second, titanium dioxide nanoparticles by S. Mashed. He said that it has been demonstrated that the final version of the titanium dioxide powders depend on the size, morphology, and also crystallized process of the titanium dioxide powders. And lastly, mechanical properties enhancement by Aramin E.N. They stated that based on the study of their anti-friction super hard coatings for drill bits and boring cutters, the measured micro hardness of the plate drill with coating is significantly higher than the normal micro hardness of a plate drill. Okay, for the third topic, which is methodology, after gathering all the equipment needed, the titanium sulphate TiOSO4 will be added with distilled water for the hydrolysis process. This solution, titanium sulphate solution will be divided into three different samples for three different temperature used. After that, the solution will be stirred on a hot plate at 80 degrees Celsius, 100 degrees Celsius, and also 110 degrees Celsius for 8 hours straight. After that, we can see the white precipitate form, and this white precipitate form will be washed with distilled water several times. And for this experiment, all three samples had been washed with distilled water for 5 times each. After that, after the last washing procedure, all three samples will be dried in an oven at 120 degrees Celsius for 10 hours. After that, the three samples will be add to the one more sample of commercialized titanium dioxide powders, and all 4 samples will be sent for the characterization process. And for the morphology characterization, the sample will be analyzed by SEM. And for the physical and structural characterization of the sample, SRD and FTIR process will be deployed. Okay, for the fourth topic, which is result and discussion, from the experiment, various data had been collected, and this data ranging from the material properties of the product, sizing of the titanium dioxide nanoparticles, and also morphology of the titanium dioxide. 4 samples were collected, namely sample 1, sample 2, sample 3, and sample 4. And this sample 1 to sample 3 is the experimental sample, and sample 4 is the commercialized titanium dioxide powders. All the collected data were used for further study of the product, and the analysis process for the sample consists of SEM, SRD, and also FTIR. For the first analysis process, which is SEM, as you can see here, we had 4 pictures, which is sample 1, sample 2, sample 3, and sample 4. All the picture had the magnification rate of 1000 with a reference to the 5000 magnification in the circle on each picture. So from this, we can see the agglomeration rate of the samples, the sizing of the nanoparticle of the sample, and also their morphology. From this, we can see that the commercialized has the more dispersed morphology. And for the experimental sample, we can see that sample 1 has the most dispersed particle. Also, we can see that from the experimental sample, which is sample 1, sample 2, and sample 3, sample 1 has the smallest nanoparticle size, and sample 3 had the largest nanoparticle size. Okay, for the second analysis, we use XRD, and from the chart, as you can see from top to bottom is sample 1, sample 2, sample 3, and also sample 4. From this, we can see that all the sample had almost the same peak position. And also from this SRD analysis, we can use the Shearer equation to find the crystallite size in nanometer for all the samples. And as you can see here, sample 1 has 60.6857 nanometer. Sample 2 had 56.19 nanometer. Sample 3 had 11.35 nanometer. And sample 4 had 42.275 nanometer. From this, we can also justify the finding in the SEM, which shows that the sample 1 and sample 4 had the smallest nanoparticle size, and sample 2 and sample 3 had the largest nanoparticle size. And the last analysis we use is FTIR, and FTIR spectroscopy is an established technique for quality control when evaluating industrially manufactured material, and can often serve as the first step in the material analysis process. As you can see from the chart on the right side of the presentation slide, and from top to bottom is sample 1, sample 2, sample 3, and sample 4. It all have the same peak position, and all the samples shows almost the same sign of peak. We can see from the chart here, and there is huge presence of NH in all the sample, which means that the samples all undergoes hydrolisis process, which is great. And the data received from the analysis process also shows the bonding, or we can say stretching process of titanium dioxide particles. This shows that the titanium dioxide particle had been bonding in the during the hydrolysis process. And lastly, for the conclusion, synthesized process of titanium dioxide powders via hydrolysis process using titanium sulphate as main material is achieved. And we can say that the morphology, sizing, and agglomeration of the titanium dioxide particle depends heavily on the temperature used using experimental process. And based on all the sample with the reference to the commercialized titanium dioxide sample 4, it is found that the low temperature produce more particle with better agglomeration, better morphology, and smaller nano-sized particle. As we can see on the sample 1 from the 3 sample of experimental titanium dioxide. Sample 1 has the better agglomeration, well dispersed, better morphology, and also smaller nano-sized particle compared to 2 others. And we can say that all the objectives have been achieved and all the findings will be used for further research. Other than that, for the recommendation, in order to obtain more accurate reading and result, more experimental temperature can be used. As you can see from the experiment, we only use 3 different temperature, which is 80 degrees, 100 degrees, and 110 degrees. Then other titanium-based powders can be used as main material for the synthesis process via hydrolysis method. For this experiment, we only use titanium sulphate as the main material. Other than that, other titanium-based powder also can be used for the synthesis of titanium dioxide powders via hydrolysis method. And lastly, experimental stirring time can be used as the manipulated variable, while the experimental temperature can stay as the constant variable. Vice versa to this experiment, which we use experimental temperature as the manipulated parameters, while experimental stirring time is be used as the constant variable. I think that's all from me. I hope you enjoy it.